Let's now focus on message transfer agents, in particular Postfix. We're going to install it on the system, as RPM Query All will show us momentarily when we quit the interface that it is not installed. We'll grep by Postfix. However, SendMail is installed by default. And we'll set up a section labeling it Postfix MTA. And it features a message transfer agent, or an application which is responsible for delivering messages to your users, usually to the local user's mailbox, but optionally to a remote user's mailbox. So it's a message transfer agent, and it's highly configurable, highly customizable. It's also modular. So for example, you can include support for spam via Spam Assassin, and have Spam Assassin work with Postfix along with other tools that perform content check and others. Now let's look for SendMail. SendMail is the default MTA included with Red Hat Enterprise Linux, and it has been for years, even prior to the Enterprise series. So this is what's installed, but we prefer Postfix. It's easier to configure. It's modular. It's not monolithic, as is SendMail. So with that said, we need to install Postfix. Now there's a utility that Red Hat provides for switching between the MTAs, SendMail and Postfix. And there's a package that you may install to help you effect that change. Let's Control F and search for System Switch Mail. This package provides a utility which allows you to switch the MTA, and there's a GUI version of it as well. So we'll need these either or to perform the switch from one to the other, from SendMail to Postfix and vice versa. So note, use System Switch Mail package, either the GUI or text version, to switch between Postfix and SendMail. So with that said, again, let's set up our tasks area. The first task will be to install, as usual, Postfix. And that's effected by using yum, since we have a repository, install Postfix. Let's try to do so from the shell on our local system. Clear screen and Control-Shift-V. This will attempt to install Postfix from the remote server. There you see it's installing it, and momentarily we'll have it installed. Let's RPM Query All, grep System Switch to search the RPM repository to determine whether or not, although we can clearly see from the output that it has not RPM, that is, installed the switcher utility. The Postfix is indeed installed. And again, before we set it up for production use, we'll ensure to install the switching utility. It's not that you absolutely need the switching utility, but the switching utility makes the process less painful. Let's RPM queryless Postfix and examine the contents. Here's a package that includes, as is usually the case with most RPM packages, lots of documentation. There's a PAM entry for authentication with SMTP. A main etc Postfix directory. This is the primary top-level container for configuration files. So let's just note that. Primary configuration directory container. And let's continue looking through. Beneath etc Postfix are key files, including main.cf. This is the primary configuration file. This is where you will make the bulk of your changes, but there are other configuration files such as master.cf, which handles pointers to deliverers like local deliverers, and other items such as a transport table, which allows you to write rules which govern the transport of specific domains, messages to specific domains. For example, if you mail a business partner or a specific domain and would like to send those messages using a specific SMTP server, the transport file is the table or text-based database file which gets converted to a DB file using postmap that you'd want to place your changes in. And Postfix will read this file to make the determination as to whether or not the message that's being currently sent matches any of the rules in Postfix, etc Postfix transport. The virtual file maintains a list of virtual users. Let's just copy these two items because they are important even for basic usage. So contains routing rules for domains. For example, again, if you want to send, let's say, messages destined to AOL.com via a specific mail server, then you'll update the transport file. And virtual contains virtual user mappings, which we'll be looking at as well. So for example, we can set up for the domains that we route various aliases that point to a specific mailbox so that we can appear to the world to have multiple accounts or have multiple people behind those accounts. There's an access file which controls access to the MTA, and you can restrict access based on IP address if you'd like, and other items. Now beneath user live exec Postfix, you'll find the binaries that are responsible for controlling or running the Postfix environment. Again, as we mentioned, in contrast to SendMail, Postfix is a modular, non-monolithic application. And as a consequence, that means there are many binaries responsible for handling the whole MTA process, from receiving connections using TCP to delivering locally versus remotely, to queuing the items, piping them, so on and so forth. Here's a TLS manager. It handles transport layer security related mails. Then there are administrative binaries that allow us to administer the MTA. One popular binary when working with mapped files is PostMap, which allows you to convert a text file, such as virtual or transport, to a DB file, which is read dynamically by the running Postfix daemon. Another one's PostQ allows you to interrogate the queue. PostSuper allows you to manage the queue, such as removing or doing other things to jobs that are currently in the queue, and others. PostConf, another useful utility, dumps the current configuration of the running Postfix daemon. So again, it's modular and it supports many of the features found by other MTAs, including TLS support. Now we do need that system config or system switch utility, so we want to install system switch-mail, and we'll just note that in our documentation that we will do this. So to install system switch mail package. Again, of course, like all things, this is not an absolute requirement. It simply makes the process a little bit easier. Let's try this from the shell. And again, there's also a GUI version of the switch utility which would launch within our GNOME interface. This will search a repository for system switch mail, and now when we type system switch mail, it's available and will allow us to switch mails. So our next task is to actually switch from SendMail to Postfix. So third task, switch default MTA from SendMail, which is the default, to Postfix. Again, this utility will take care of the general startup files, unit D entry and the sysconfig entry, as well as other entries that are related to startup. We should also note that Postfix is a drop-in replacement for SendMail. It indeed provides a SendMail binary. We should just note that as one of the features. It's a drop-in replacement for SendMail, as it provides a SendMail binary which accepts the options supported by the native SendMail binary. So with that said, let's switch the configuration by executing system switch mail, which launches this curses text or ncurses text-based interface. We need to choose the primary MTA at this stage, navigate to OK, and that's it. As is the case with most simple Red Hat utilities, not much is echoed and the interfaces leave a lot to be desired, but nonetheless, providing there are no exit statuses other than 0, you should be able to surmise that the process has executed successfully, which is why we have echoed the exit status. So now, postfix is the default. And if you rerun system switch mail, you see that the bar is highlighted over postfix to indicate that it is the default. It would be nice to see a little asterisk or plus sign or something more intuitive, but nonetheless, it is what it is. And now postfix is the default MTA that will start in our system. Now, as far as whether or not it's actually running, you can PSEF grep the master utility. The master program is the master binary, master daemon that is, supported in postfix, which spawns the other daemons when necessary. A daemon for routing the messages inbound, outbound, binding to TCP, so on and so forth. So user lib exec postfix master is running. Another test would be to execute nets.mtlp grep 25, where you should see that the master process has control of port 25, albeit on the loopback adapter, which brings up another point. So we've switched by executing system switch mail, and then we've selected obviously postfix. And note the default postfix configuration binds to the loopback adapter address. So we will need to change this if we intend to route messages in from other hosts on the wire, which leads us to our fourth task, and that is to configure postfix to receive messages from remote systems. Now, in its current configuration, postfix will deliver messages. If you use a utility such as MUT and send a message to yourself, it'll work. Let's just insert that as the fourth task before we move on to accepting messages from the wire. So the fourth task is to test local mail delivery, because obviously we cannot test remote mail delivery because postfix is currently not listening to all IP addresses or a routable IP address. So we'll use the MUT utility, which is a text-based utility, to test local delivery. And when using MUT, you can specify a local address or a remote standard SMTP email address. So we're logged in on Linux CVT Server 4 as the user root. Which MUT tells us it's in user bin. We launch MUT, and here we see messages from LogWatch as well as one that appears to be for the certificate for site1.linuxcvt.internal. And this was sent as a result of executing GenKey, and it tells us that it will expire in 29 days, which is fine. Besides all of that, let's delete everything in MUT. To delete everything, execute upper D and use a regex pattern of .star, which means all matching characters 0 or more times, and that applies a D or a delete directive to all 19 messages. This will delete everything, and if we quit, it'll prompt us to purge the 19 messages, and then we'll re-enter where you'll see no messages. So again, very simple to delete messages and to mark them. To send a new message, press M instead of N, which would be a little more intuitive, but M is used to compose a new mail, and we'll send that new mail to root, who we currently are logged in as. Testing local delivery. And notice below, MUT echoes where exactly, or the path to the mailbox that it currently has open. var spoon mail root, which is stored in a local variable named mail. If postfix is set up in its default configuration, it uses mbox format, which is what's represented here in var spoon mail root. However, if you reconfigure postfix to support maildir, which is a superior way of storing messages, which splits out the messages into distinct files, then you'll need to configure MUT using the maildir environmental variable instead of mail to point it to the location of your maildir, which is usually beneath the user's home directory, beneath a directory named maildir or mail or something similar. So wherever postfix delivers mail and however it does so, you need to instruct your mail user agent, which in this case is MUT. And with that said, it launches us into VI, the default editor. To insert a line, go ahead and press I and then type, "This is a test," or something along those lines. When complete, you press escape then Shift: returns you to the prompt. WQ writes and quits the interface, and now we have a message that will be sent in PGP clear text to root at linuxcbt serve4.linuxcbt.internal. So by virtue of typing in root, the fully qualified domain name was appended to both the sender and recipient's email addresses. The subjects there, no CC or BCCs, have been specified, although we could impact them using C for CC, B, BCC, so on and so forth. We could attach an item if we'd like, using A to attach a file. But barring no additional features or desires, we can go ahead and send this message. But before we do, which is indicated using the Y option, also note that the text, the actual body that's to be included, and since it's text, it'll be included in the body of the message, is stored in the /temp directory as mutt, followed by the name of the host, followed by a unique identifier. We did mention earlier in our studies that temp is a location that is flagged with T, so it is the type of directory where users cannot clobber other users' files, and is a general all-purpose directory for storing items such as mail attachments. So if you attach a file, it will be spooled to temp, or if you create a text inline message, it will also be spooled to temp, and then once sent out, it will be included in the body of the message, or if it truly is a separate attachment, then there will be an attachment. With that said, let's press Y to send the message, and this sends it off. Now what exactly happens in the background? I've moved the arrow key up and we see the message, and we know that it's new because it has an N flag, and if we press enter, we'll see the contents of the message. Well, before we get into all of what's happening in the background to deliver the message, which is truly postfix related, we see the headers, or the header that is, which includes multiple items, when the message was sent, who it was delivered to, who it was originally sent to, because Postfix, if it performs a translation using the virtual table or the alias table, will translate the message from who it was originally meant for, let's say sales at the fully qualified domain name, to the ultimate user if there's some sort of translation. In this case, no translation was necessary. It's the same original and to email address. And again, the date's included, who it's from, who it's to, the subject, the user agent is also included, and the body is included. Now behind the scenes, what actually transpires? If we quit mutt for a quick moment, and we take a look at var spool mail, we'll see the various mailboxes. In this case, only one for root. It's currently empty because we didn't save the message. It ultimately gets stored in root's home directory in mbox format. When mutt sends a message, really what it makes is a call to send mail. Send mail is available to all users on the system, but a call is made, and when that call is made, send mail, which is a Postfix plugin, and it is executable. Let's list it in long form, LSL, so that you see the permissions on it. This send mail binary is a binary which links, as you can see, to alternatives MTA, so LSL, etc, alternatives MTA. This is a Red Hat convention, a Red Hat way of doing things. And then it ultimately points to user sbin sendmail.postfix, so it's a symlink. So when we finally get to the file, we see that it's owned by the user root and the group root, but it's also executable by everyone else, which is why we're able to execute it. So mutt calls sendmail, the binary sendmail, which is provided by Postfix, places the item into the Postfix queue. Postfix, because it is running psef grep either post or master will reveal it, picks up the item, the queue manager notifies, and it picks up, and then it sends or delivers the message locally. And if it is to deliver it remotely, then Postfix will use its SMTP client, which is a separate process, to deliver it. So again, RPM query list Postfix reveals the embedded items. There are multiple binaries responsible for multiple jobs. Scroll up through past the documentation. All these user lib exec items that you see here are responsible for different things. Got a local deliverer, an SMTP client versus the daemon. The SMTP-D listens to port 25 or whatever port you indicate. The SMTP is a client which will send your message to an SMTP server on behalf of the sending application, such as mutt or evolution, or a connecting client using, let's say, Outlook Express or even Outlook. So the message was delivered locally directly into the queue by SendMail, and then Postfix moved the message into the appropriate user's mailbox, which is located in var spool. And let's just go through our history. Var spool mail into the user's mailbox. Now it's empty at this stage because the MUT program moves mailbox messages into the user's home directory into a file named mbox, which you can cat because it's simply a text file. There's the original message, this is a test, it's not encrypted, so on and so forth. So that's what happens behind the scenes. So we've configured, or we've tested local mail delivery using MUT. Let's test delivery to one other user. We'll launch MUT once more, M for new message, we'll send it to Linux CBT, testing delivery using MUT/Postfix, and it propels us once again into VI, which we'll use I to insert, and we'll just indicate test, test, test. Escape, Shift:WQ, and then Y to send the message. Again, MUT has translated Linux CBT to mean, the local user that is, Linux CBT at the FQDN of the local host. Our email address has been translated to mean the local user who we're logged in as at the shell, followed by the fully qualified domain name of the host. Y to send, and we can quit, and from a separate shell as the user Linux CBT we'll be able to read the message. Now, to determine if it was delivered, if we lsltr var spool mail, we'll see momentarily, a new file has been created for the user Linux CBT, and it's 738 bytes. So we don't need to use MUT as Linux CBT to confirm it, but if you'd like to, we'd SSH in locally. So SSH is Linux CBT at localhost, and attempt to authenticate. And once in, we'll launch MUT, and it tells us home Linux CBT mail doesn't exist. MUT wants to create this directory, and there's that new message. Testing delivery using MUT. We can use R to reply to the message, and each menu that you're in is context sensitive. So when you're viewing a message, then you can reply, view the attachment, or exit using the various options. So we'll reply. This will also propel us into VI unless we have a different editor. And in the body we'll just say got it. Escape, Shift:WQ, then Y to send. The message will be returned to root at linuxcbt-serve4.linuxcbt.internal. And then we'll quit, and then quit the interface altogether. We'll exit the SSH shell, and again we can confirm using ls that root's mailbox has been updated, and as you see it's 949 bytes. And in Linux CBT's mailbox, which we can take a look at using lsltr, we see that a file has been created, mbox. A directory has also been created named mail, but subdirectories are generally used, when you see a mail subdirectory, is generally used for maildir related messages. Also, we did mention that there are variables set, at least a mail variable set, and optionally a maildir variable set. Execute set grep case insensitive mail, and you'll see what's set. Mail is set to var spool mail and the name of the user. So when you log into a fresh shell using SSH, the mail variable is set. Mail check is also set. So every 60 seconds, MUT will check to see if there are new messages and refresh the interface when you're within MUT. Or in this case, the shell will check every 60 seconds and tell you if there's new mail. So if we're idle for 60 messages and new messages come in, then the shell will tell you, as opposed to MUT. It makes use of the shell, that is, the mail check variable. So with that said, we can deliver locally. Now let's move on to the next task, and that is to configure Postfix to receive messages from remote systems. So there are a few things we need to do here. We need to ensure that Postfix listens to all interfaces by setting the inet interface variable. So set inet interfaces equal to all. This will ensure that it listens to, it being Postfix, listens to all IP addresses, or you can set it to a specific routable IP. In addition, we need to set my destinations. So set my destinations equivalent to any domains that we should route messages for, such as linuxcbt.internal. let's go ahead and modify the primary config file. In etc, we'll use nano-main.cf, and that's postfix, etc postfix. And then we'll search for my-dest, which will lead us to the area where the routing of domains occur. And we'll see where the variable gets set momentarily. We just have to keep scrolling through this interface, and we see relay domains, many other variables. You can determine who may relay off your system, and we'll keep going through. And right now we're only 39% through the document, so let's keep going through it. Scroll up to the top, and we'll scroll through one page full at a time. The Q directory is var-spool postfix. This is where messages will be routed beneath the postfix top-level directory. The command directory is sbin. The daemon directory is user-lib postfix. The owner of messages is postfix by default. And we'll keep searching one page full at a time. And we should be searching for my destination without the $sign. Here's the inode interfaces. Let's copy and paste this using Control-K, Control-U. We'll comment the one which reads localhost and change it to all, and then keep moving forward. You could again specify a distinct interface. Here's the my destination variable without the $sign, and there are also some suggestions for how you may indicate my destination, which includes, but not limited to, setting my destination to my host name. My host name will translate to the FQDN, which is linuxcbt-serve4.linuxcbt.internal, which is why, by default, Postfix accepts messages constructed by MUT to a username followed by the FQDN of the local system. It also accepts messages to localhost.mydomain, so localhost.linuxcbt.internal, and also messages destined to user at localhost. If you want to handle a specific domain, then cut and paste the default, comment one of them out so that you have it in the event of any issues, and then append using a comma separator following the delimiter used, but commas and spaces are supported, and it tells you above, separated by commas and or white spaces, but to be consistent we'll just use a comma, and indicate that we want to support the domain linuxcbt.internal. Another way to do this is to assign my origin to linuxcbt.internal and then set my destination equal to my origin using a $sign. That works as well. So we will now handle linuxcbt.internal and will now listen to all interfaces. Now, of course, if you're sending messages from a remote system, you need to ensure that the MX record points to the IP address of this postfix server so that sending SMTP servers can find this destination server. And again, there are many other directives in here. We won't go over all these. For a deeper look at the Postfix environment, look at linuxcbt Postfix Edition, or if you want to study sendmail, Postfix, QMail, look at mail edition altogether. But we're just going to set some of the basic variables to get mail routing. Now, once we've made the change, we should restart, or the change is, we should restart the server using, of course, service postfix restart. And if there are any errors, then of course the service will not restart properly and a non-zero exit status will be returned. Let's echo the exit status. It's clean. Let's netstat ntlp grep25, and now we see postfix listening via the master process to all IP addresses, which means we'll be able to connect to the server from remote systems. Doesn't mean remote systems will be able to relay through this server, but it does mean that this server will at least accept their connection and be given the opportunity to determine whether or not it should accept messages from connecting clients. Now there's another utility. Let's just go ahead, confirm directives using postconf, and that's this other utility that we alluded to briefly when we were looking at the contents of the Postfix RPM package. Postconf dumps all of the currently set variables. as Postfix sees them: TLS, the ciphers, virtual maps, transport maps, SMTPDs, so on and so forth. If you've changed some of the variables, then use postconf and then grep the name of the variable you're interested in, such as my destinations. This will reveal the my destination that's set. And we should see momentarily, there it is, my destination equals hostname, localhost, linuxcbt.internal. So this tells us exactly the domain types, the formulations that the server will accept mail for. And we've also changed inet interface, so let's look for inet_int, and you'll see inet_interfaces equals all. So the postconf utility is helpful in dumping information regarding set variables, but it also can be used to set variables from the command line. So if you wanted to change something dynamically without updating the config file, you could use postconf as well to change or make the changes dynamically to the running server. So use postconf for that particular reason. Now, with all of that said, we need to attempt to send a message to, let's say, the user root at linuxcbt.internal. But in order for this to work, when a lookup is performed, let's say from the remote system, which is to us locally, because this is where we're connected to currently, but from the perspective of mail, it's remote. So let's say from serve1, we want to send a message to serve4. From serve1's perspective, first and foremost, take a look at the resolve.conf to see which server will be consulted first. And we did comment in our recent studies to speed up name resolution when we were looking at Apache. We commented out the Windows server, which took a while to respond, possibly because it was off at the time that we were doing Apache studies. So long as the server, the primary or the available, any of the available DNS servers will return or resolve lookups for MXs for the linuxcbt.internal domain, then the SMTP instance on this system will be able to communicate with the SMTP instance on the remote system. So let's dig linuxcbt.internal MX to see the perspective from the linuxcbt serve1 box. And as you can see, it knows the MX because we wrote it to be linuxcbt serve4, which ultimately gets translated to 192.168.75.199. And you can always look up the item distinctly using dig. And this tells us that indeed in the answer section it's 199. This means when we send messages, it will connect to 199. So on the remote system, let's launch mutt, remote meaning the system we're currently logged in at. Delete these superfluous messages using upper D. Quit, clear it out, relaunch. New message, root at linuxcbt serve4.linuxcbt.internal. This is one way to test if it'll send it based on its FQDN, and we'll say testing using FQDN, not using the MX record. This is a test of mail delivery using the FQDN, not the MX record. This is just to see whether or not a message can be transmitted from the local system to the remote system using its host name. So we'll escape shift:/WQ and then Y to send. So now locally, our system will attempt to send a message, and we can confirm whether or not it has by executing mail queue. If you see that the message is stuck in the queue, that means it has a problem resolving linuxcbt serve4.linuxcbt.internal. As you can see here, the sender is on the serve1 box trying to reach a similarly named recipient on the remote system. Now the queue is empty, so guess what? It took a little bit to resolve, but it ultimately resolved because the queue is now empty, and you can confirm by tailing var log, where the mail log is stored, mail log. And there we will see that the message was sent to the remote system. It said host not found, linuxcbt serve4, host not found, to root at linuxcbt serve1. So this could have yielded a bounce. Let's take a look, and there's the bounce. It was unable to find linuxcbt serve4, host unknown. So this yielded a bounce. That means from the shell, if we attempted to ping linuxcbt serve4, linuxcbt.internal, an error should be returned. Here it actually returns 192.168.75, 199. Now that tells us a few things, or it tells us one thing in particular. If we netstat NTLP grep 25, we'll see that the local, what appears to be, in this case, sendmail, is bound to the loopback adapter. And because it's bound to the loopback adapter, it cannot initiate a routed outbound session. So it's not that it doesn't know who the host is. It does. It just cannot perform a connection outbound because it's bound to the loopback adapter. Again, a dig Linux CBT serve 4.linuxcbt.internal performs the same query performed by any MTA, sendmail, qmail, or postfix. So the error isn't even misleading. We should just note that. So E attempt to send message from Linux CBT serve 1 to Linux CBT serve 4, and it fails. If it fails, configure MTA on Linux CBT serve 1 to listen to routable IP address. Now it's running sendmail. Sendmail supports, of course, changing the interface that it listens to. In fact, sendmail's configuration, that is located in etc mail, and its primary config file, sendmail.cf, is created from sendmail.mc. This file contains macros which get expanded using the M4 macro program to appropriate sendmail lingo. And in here you will find where sendmail actually binds to the loopback adapter, and you can either comment that line out or change it to the address. Here, daemon options is set to address 127.0.0.1. You can either set this to all zeros or comment this line out altogether and restart sendmail. So, nano sendmail MC will find 127.0.0.1, and for this line again, you can comment it out, and it tells you here it only listens to the loopback address. Remove it if you want it to accept messages from the intranet or the internet, or you could set it to all zeros. That's an option. That means to listen to all IP addresses, or you can comment it out altogether as follows. Either or will cause sendmail to listen to all IPs. Now, one of the neat things of using, or features of using sendmail within Red Hat Enterprise or Red Hat altogether, even as far back as version 9, is that when you restart the sendmail server or service, it recompiles a new sendmail.cf based on the sendmail.mc, which means we can simply make changes to the MC files and have the changes effected rather quickly. Now, of course, we will use service sendmail restart to restart the server. But before doing so, we just want to point out one other thing, and that is there's a required package in order to be able to recompile sendmail items. It's sendmail-cf. This package must be installed on your Red Hat Enterprise box in order for you to update the resultant sendmail.cf file by using either the make process or restart. Now, using the make process, you'd execute make all etc mail with the C option. And if there's nothing to be done because we restarted the server that already has the appropriate sendmail-cf package installed, that's this package here, sendmail-cf, then there'll be nothing for it to do. So then you simply restart the server, and that's it. So there's the sendmail-cf for 8.13. It will kill the search and then just restart sendmail once more and then execute netstat NTLP grep 25. And now it's listening to all IPs, which means it can communicate out on the wire. So let's just note, if it fails, configure MTN to listen to routable IP by doing the following. Update etc mail sendmail.mc. You'll see the option which binds to the loopback adapter, and then execute make all after you've completed upper C etc mail, and then restart the service using service sendmail restart. And we should just note, ensure that sendmail cf star package is installed in order to update .mc files to .cf files, in this case file, because it is, it will indicate files. It is monolithic, but nonetheless, most of the settings are spread across one or two files. So let's attempt to send mail again using MUT from our local system. New message, root at Linux CBT serve 1, or 4 that is, from Linux CBT serve 1, internal. This will propel us into, after we indicate, testing routed mail without MX. And now we're in VI, insert, testing without MX. Save the changes, Y to launch the mail. Now before we consult the remote system's MUT, let's consult the local system's mail log, tail var log mail log. We should see that the message was sent relative to our current time, which is 1446, was sent at 1445 by sendmail, PID 23409, to root at Linux CBT serve 4.linuxcbt.internal. This is the sender's address. The delay was none because it was sent across the LAN, and the relay that was used was Linux CBT serve 4.linuxcbt.internal, which translates to 192.168.75.199. The message was sent OK, which means on the remote system we should be able to launch MUT. And before we do so, let's just lsltr var spool mail. We should see that root has a mailbox which has grown roughly at 1445 or later, and we can compare it to the current time, which is only a little over a minute after, and then MUT will reveal the message from that user, and there it is. So we can use the message, we can reply to it, and it'll end up back on the remote system. We'll reply, insert, got it. Shift:WQ, Y to send, and it'll be gone to the remote system momentarily. Now notice, mail delivery, this through an error, could not find the target system, Linux CBT serve 1. Why is that? Let's return to the shell on Linux CBT serve 4 and ping C3 Linux CBT serve 1 to see what it thinks about it. Doesn't know. Let's try the FQDN. Still doesn't know. That's because hostname resolution isn't properly configured. So with that said, and if we were to dig at 192.168.75.199, Linux CBT serve 1, Linux CBT.internal, it comes back with no answer. So with that said, if we place an entry into etc hosts for the hosts, 192.168.75.10 for Linux CBT serve 1, Linux CBT.internal, and a short name of Linux CBT serve 1, and then attempt to send the message using MUT, new message off to root at Linux CBT serve 1, Linux CBT. In fact, we can just change the current message or reply to the original message. We've deleted it, so we'll create a new message off to root at Linux CBT serve 1, internal, testing without MX. We'll insert test without MX, Y to send, we'll quit, and then check mail queue using mail queue. It's empty. Then we'll tail var log mail log to see the status of the message as it was sent, and we'll see to root at Linux CBT serve 4 delivered to mailbox. And now we relaunch MUT on our local system, and an undelivered shows up because again it did not use the name resolution, so it's still unable to find Linux CBT serve 1. We have to fix the DNS issue. It did a lookup, did not find it, and it says the name service error yielded the inability to find the host, but that's fine. It just proves how important a properly configured name resolution environment is. Now back to the issue of sending from Linux CBT serve 1 to the domain using the setup that we have in place. When we dig from the system the domain linuxcbt.internal mx, it comes back with 199. That's this host. Which means if we launch mutt and send a message to, let's say, root at linuxcbt.internal, the remote system will receive it. Testing mail with mx. This will use DNS and mx record to help deliver the mail. Let's save the changes, send it, quit, tail var log, mail log. And as you can see, the message was sent to linuxcbt serve 4, which means mail queue should be empty, and it is. Back over on serve 4, when we launch mutt, there's the message from the host, and it was originally sent to root at linuxcbt.internal, and it was delivered to the appropriate user. So we've got MX records working at this particular stage. The only issue we have not resolved, which is not a big deal, on linuxcbt serve 1 is its ability to use DNS to look up linuxcbt serve 1.linuxcbt.internal, but that's a small issue. It's minute. Configure DNS appropriately, ensure that the local system can access the appropriate view, or restart the Postfix instance so that it uses etc hosts and the message will be delivered in that particular case. But the ideal situation is to make sure that DNS is set up properly.